how to state other characteristics of functions. So first of all, we need to identify an interval of increasing or decreasing. So how do we find interval increasing? That means when we plot a point on the graph and we draw a tangent line through that point, we will see that the tangent line has positive slope. For example, I will pick the interval from -4 to 4 right here. And if I pick any point on the graph, maybe this point right here, and I draw a tangent line through this point, that my tangent line has a positive slope. I can choose another one and choose this point right here, draw a tangent line, that my tangent line also has positive slope. So therefore, with an interval from -4 to 4, I will have the increasing. So I put in increasing interval will be -4 and 4. And few of you may confuse which notation of interval should we use. Is it parentheses or is it bracket? So the answer is, if you pick a point right at -4 and you draw a tangent line. So what we see is we see a horizontal line, and that means the slope of this horizontal line is 0. So if it's 0, we cannot say it's increasing. Therefore, we will not include the -4 as the increasing interval. And same thing, we draw a point, we put a point at 4, we draw a tangent line, we see the same thing, horizontal line. Therefore, we don't include 4 in our increasing interval. So increasing interval is only from -4 to 4, but not include -4 and 4. Alright. Okay, so now we can look for decreasing interval. So for decreasing interval, I can try put a point right here, and if I draw a line, tangent line, I see my tangent line is going down, so that means my tangent line has negative slope. And I can pick another one, draw it. I have a tangent line that has negative slope again. Oops. Okay, and then for this interval right here, I can pick a point and draw a tangent line, it's negative slope, a point, tangent line, negative slope. So now I will state the interval for decreasing. So my interval, and I see my graph keep going all the way to the left, therefore it has to be -infinity, and then stop at -4. And like what we mentioned earlier, at -4 we have a tangent line that has 0 slope, therefore we cannot include a -4 in increasing interval nor decreasing interval. So we have this one. So both them parentheses. And same here, we have 4 go all the way to the right, so it will be +infinity. And we cannot include 4, so therefore it will be parentheses for both. So we have decreasing interval will be -infinity to -4, and then 4 to +infinity. Alright, so that's the answer for state increasing or decreasing interval on the graph. Okay, next we talk about concave up and concave down. So what does it mean by concave up and concave down? So concave up, concave up is look like this. Okay, so you have a parabola but facing up, and then concave down will be facing downward. So on the graph, if you look at that, you will see that the interval, so this part of the graph right here is concave up. And yes, don't forget this is the asymptote at y equals 0. So therefore your graph keep going, but it reached very close to 0 but never passed the x-axis. So therefore this graph right here, you have concave up, and the interval will be negative infinity, and it stop at 0. Okay, so concave up will be negative infinity to 0. And then for concave down, you see that this part right here is concave down. And this interval will be 0 to positive infinity. So put concave down with 0, positive infinity. And some of you may have questions about why don't we put brackets for 0. So the reason is at 0 is the turning point from concave up to concave down, or the other way on some graph, it can be concave down to concave up. And this point right here, we don't include it because it's turning point. So we'll call this point right here as inflection point. And it's also part of your characteristic of function. And the coordinates of this inflection point will be 0, 0. Okay, next we talk about relative max or relative mean. Alright, so first of all, we need to look at our graph, and we know this keep extending, but it's never cross the 0, so it's go like this. Okay, and same here, keep going, but never cross 0. Okay, so then for relative max, the highest point on the graph will be this point right here. Because on the graph, you don't find any other point that's higher than 4, 2. So because this is the highest point, and highest point usually is only one point. Because it's highest point, so therefore it will becomes absolute maximum value of this graph. And we don't have relative maximum for this graph. And then same thing, we have the lowest point on the graph is this one right here. So this will becomes a absolute mean or minimum point for this graph. And all you have to do is state the coordinates of the point. Whenever we talk about point, we state the coordinates. So this will be 4, 2 will be absolute max. And then for this one, we have -4, -4, -2 will be absolute mean. And besides we call absolute max or absolute mean, we also call them global max or global mean on the graph. So they are the same. And then for relative max or relative mean, we don't have any, so they are none in this case. Okay. All right, let's move on. Next example. All right, so for this one, first we talk about concave up, concave down. No, actually, interval of increasing and decreasing first. Sorry. So interval increasing, I see that this part right here will be interval of increasing, because if I draw any tangent line within this interval, I see my tangent line has positive slope. So now I state the increasing interval. So it will be from -1 and stop at 0, and then from 1 to infinity. Now I will look for decreasing intervals. This one right here. So my decreasing interval will be -infinity to -1, and from 0 to 1. Okay, next part. So when you do the second example, maybe you can pause before I give out the answer for each characteristic. So maybe you can work on it first, have your answer before you keep playing it, the video, so then you can see whether your answer matched to my answer. That's a good way to practice right there. Okay, next we talk about concave up, concave down. So concave up, I see this part right here is concave up, and right here. Okay, I cannot go all the way right here, because when I go to this part, it's already concave down. Okay, so therefore we just stop half of it right here. So then I have concave up is -infinity and stop at, and I estimate it right now at this level pre-calculus. I just estimate the inflection point, -0.5, and then I have another one which is 0.5 to positive infinity, and then the other part will be concave down. So for concave down, I have -0.5, 0.5. Okay. All right, we move on. Oh, and since we do concave up, concave down, it's easier for us to state point of inflection. So point of inflection is where you see the yellow color turn into green color, and from green color turn into yellow color. So this point right here. So my inflection point is -0.5, comma -0.5. That's the first one, and the second one is 0.5, comma -0.5. So this inflection point. All right. Okay, and next we try to find whether absolute max or relative max, or absolute mean or relative mean. All right. Alright, so on the graph, you see, first we notice the graph has 2 arrows, so just keep going forever. And if it's keep going forever like that, we don't have any highest point on the graph, or we don't know exact which point is highest on the graph. So therefore, in this case, we don't have global max, or we don't have absolute max. Okay. However, we see that within the interval, so within this interval right here, we have a maximum point which is 0, 0. So this 0, 0 is our relative max. Or we can call it local max. Again, the difference between local max and global max, or absolute max and relative max, is for absolute max or global max, it has to be the highest point on your graph for entire of the graph. But local max or relative max is only a maximum point within an interval. Okay, and same thing with the mean value. If it's the lowest point of the entire graph, then that will become global mean or absolute mean. If it's just a minimum point within an interval, so it will be relative mean or local mean. Okay, and then next we can find, and then for the minimum value, we see these two value right here. That's the least value we can have on y, but we have two of them. When we have two of them, it cannot be considered as global mean anymore. It has to become relative mean now. Okay, so now d2 becomes relative mean instead of global mean because we have two of them. So we have -1, -1 and 1, 1. Okay. All right. Let's move on and do one more practice together. Okay, we can try this one. So first we talk about increasing, decreasing. So increasing. Increasing interval will be this part right here and this part right here. So the interval will be -infinity, stop at 0, and another one will be 2 to infinity. Then I figured out the interval of decreasing. So then decreasing will be 0 to 2. Okay, that's the interval. All right, next we talk about concave up, concave down. So we see concave up is halfway from here and go all the way up here. So concave up will be 1, the interval of concave up will be 1 to infinity. And then for concave down, we have -infinity to 1. And since we talk about concave up, concave down, it's easier if we can state the inflection point, which is the point where the yellow color turn into green color, or where concave up turn into concave down, or the other way, concave down turn into concave up. So inflection point is 1, -5. Right? Okay, next. Do we have maximum value for this graph? Okay, maybe we erase this so we can see original graph first. So as we see, we have, let's keep going. So therefore, if it's keep going like that, we don't know where's the exact point that is the highest point of this graph. And same thing, we don't know the exact lowest point of this graph. So therefore, we don't have global max or global mean. However, within this interval, okay, I will see my highest point is 0, -3. So that will becomes my relative max. And then similar to that, I will look for the other interval, and within this interval from 1 to infinity, I see that my lowest point is 2, -7, and this will becomes my relative mean. Right? So hopefully this video help you understand more about characteristic of functions.